So in this video, I'll be showing you how to use the laws of logarithms, including the change of base of logarithms, to answer questions for the IGCSE Cambridge course for additional maths. So here are our laws of logarithms. As we can see, there are quite a lot of them. These are just things that can be derived from them, so we're only going to really focus in on these. So as we can see, log of base a of x times y can be written as log of a x plus log of a y. Similar thing for log of base a, x divided by y. This can just be written as log of base a, x minus log of base a, y. Similarly, if you have a log of something and it's the something is to the power of anything, you can just take this power and put it to the front. So your log of a x n to the power n turns out to be n times the log base a x. And this right here, this is the change of base rule. We're going to use this in a later slide, so I won't focus on that now. And then this last one is just another change of base law that you can use. Okay, so this is our first example. We don't need to change any bases because everything is of base a. So we have log 5 plus 2, log of 7 minus log of 35. So we want to express this as a single, single logarithm. I've just written it out again just to make it easier to read. Also, on this first line here, we've used the power to the front rule right here. So we're going to use this in reverse. We started off with this 2 log to the base a is 7. So this is our 2, this was our 7. So now we need to put it back into this one. So that's going to be log of a, 7 to the power of 2, which we have here. So our next step is we want to use these two laws at the top. So we know that when 2 logs with the same base are added together, these can also be written as one logarithm with the 2 items multiplying each other. And that's exactly what we've done here. We've taken the 5 and we've multiplied it by 7 squared, which is 49. We also know when we have a log minusing another log of the same base, we can write them as being over the other. So this log of 7 squared is minusing the log of 35. So it's going to be 7 squared, which is 49 over 35, and we can put it into this single logarithm function to get 5 times 49 all over 35. And then we can just simplify this, so it turns out to be the log of a, and then 5 times 49 is 245, and we're just going to leave the 45. And then we can further cancel these down just to get the log of a equals 7. Example here, we have log of 1 over 9 equals minus 2 log of 3. We need to manipulate this one to show that this side does indeed equal that side. So first of all, when we take a look, we can see this 9 is the same as 3 squared. And because there's a 1 over, we know it's going to be a negative exponent. So we get 3 to the power of minus 2. And we're going to use our power to the front rule. So anything that when there's an exponent within a logarithm, we can just put this times it out by the front, so we get minus 2 times the log of 3. Another example here, we need to write this equation but without any logs within it, so we have the log of y equals x, the log of 4 plus the log of 3. Now we're going to leave this side untouched because there's really nothing we can do with it at this point, and then we're going to start with this side right here. And the first thing we're going to do is we're going to do the power to the front rule backwards, so we're gonna make it so it's the log of 4 to the power of x instead of x log of 4. We can use our multiplication rule to kind of factorize these in a way, so then we get the log of 3 times 4 to the power of x. Because we have logs on each side, same base, we can then make the counterparts equal to each other. So we get y is equal to 3 times 4 to the power of x. Example here, they want us to solve for x, and we are given the equation the log of x minus 6 plus the log of 3 equals 2 the log of 6. So one of the first things we're going to do is we're going to take this log of 3 to the other sides, just so that it's a bit easier to work with. We're also going to do the reverse of the power of the front rule, so we're going to make this 2 times the log of 6 into the log of 6 to the power of 2. After we've done those two steps, we're left with the log of x minus 6 equals the log of 6 squared minus the log of 3. And then if we use our addition and subtraction rules, when you subtract something, that's the same as putting this one over this one, dividing this one by this one. So we get that it's the log of 36, 6 squared, over 3. And then because we have two logs here with the same base, we can equate all their counterparts over here. So we get x minus 6 equals 12, which is 36 divided by 3. Then we just move the 6 to the other side to give x equals 18. The last thing you need to know is how to change the base of a log. So this is the formula we're going to use for that. It states that log of base b of a is going to be equal to log of base c, a, divided by the log of base c, b. So our example, we're going to solve this for x. So we're given log of the base of 2x equals log base of 8, 15. So we're going to manipulate this side right here, and if we use the change of base formula and all the letters they've given us here, we can identify that the a here is going to be 15, and the b here is going to be 8. And we want to change it into base 2 to match the one on the other side. So this is going to be our c value that we want to change it into. So now that we've identified all the variables that we need, we're going to put this into this side of the equation. So we turn out with log of base 2 to match this side, 15 because it's the a up here and we already identified the a is 15, divided by the log of 2 because again we want it to be in the same base as the other side, and then we're going to put b, which is 8. And then we're going to find out how we can manipulate 2 in order to get 8. And we know that 2 to the power of 3 is 8, so we do the reverse of a log, and we find out that it is 3. So we can put this as our denominator. And using our laws of indices, we can see that the log of base 2, 15 divided by 3, is the same as log of base 2, 15 to the power of 1/3. And then we can take out the log of base 2's to get x is equal to the cube root of 15.